Okay, this is 9.5. This is extra credit notes. Not required, but strongly suggested. Talking about segment lengths in circles and equations in circles. If I have intersecting lines in circles, we know that we can find different angle measures. But what's interesting is we can also find different lengths of segments. So if we have a circle on here, we have intersecting lines interacting with a circle. You can find the lengths of line segments created by these interactions. We're going to use off of the cheat sheet, the top row says circle formulas for segment length. We're going to use each one of these today to kind of show different situations. If I have two tangents, then I have the relationship that A equals B. Those segments are the same. We know that one already. We've discussed it before. Tangents intersecting outside the circle have the same length. If you look at a different type of situation, if we talk about when there's two chords, notice this is two chords. We know about their angles, but their lengths are also significant. If you go opposite next to each other, we have A over B is equal to C over D. Or if we cross multiply, we end up with AD is equal to BC. So for example, 9.32, please draw two chords. Label them as ABCD, like this. And then put in your ratio pieces and write out the ratio. A over B is equal to C over D. Extra credit points right there. Cross multiply, and you'll get AD equals BC. Okay, you're going to multiply both parts of one chord and both parts of the second chord, and the products are the same. Notice how this is one chord. We have A times D is equal to the other chord, B times C. All right. If we look at it as a secant and a tangent, we have to set up a different kind of ratio. If we take the whole length of the secant and put it over top of one tangent, then we take that tangent and put it over top of this portion of the secant, then we end up with a good ratio. When we cross multiply this, we get A squared is equal to BC. Now draw a tangent and a secant. Label the tangent segments as individual pieces. So the reason why I got this in multicolors is so you can see the different proportions. But on your if you don't have multiple colors on your notes, that's fine. Just label it like this. We're going to say this entire secant is C. This little part of the secant is B, and the tangent is labeled as A. When we write out the proportion, the whole thing over the whole thing, that gives us C over A. Then we do the tangent over the part, we get A over B. Then when we cross multiply, we end up with A squared equals BC. Your notes so that you can get free points, extra credit points. Okay, so now secant and length. We multiply the entire length of the secant by the outside piece. This is equal to the square of the length of the tangent. So you're going to say the whole, when you look at it like this, it's easier to see. You just take the tangent squared equals the part of the secant times the whole secant. The fraction might be harder to see, but if we have two secant, this is where it gets fun. The same rule applies. Make sure that when you draw the secant, we're looking for these different relationships, A, B, C, and D. Okay? If you take the whole part of one secant and times it by the portion of the other, or divide it by the portion of the other, and the whole other secant divided by the portion of the other, we end up with D over A and C over D. Sorry, C over B. Then when we cross multiply, we see a very interesting relationship. If we take the secant, C, times it by the portion of it, A, that's the same thing as B times D. So as long as you stay along the same secant and you're multiplying, you're fine. All right, if we look at this as far as when to use the two ones, when do we use what formulas? Well, right here we're looking for angles, right? Angles or arcs. We're going to use these formulas. If you know a length and you want to know a length, something like that, then you're going to use these formulas up here. Notice how this one says lengths of segments. This one says angles and arcs. There's a bit of a difference. So determine the type of lines or segments, and then choose the formula that matches and solve. So here it says find PD. When it says find PD, that means that we're going to take segments. I want each piece. I label them accordingly. I've got 4, x, 8, and 6. I'm going to go ahead and substitute in the formula. I like to do the multiplication formula. It's easier for me because I just know that I take one part of the chord times the other part equals one part of the chord times the other part. That ends up with 24 equals 8x, divide both sides by 8, and I end up with 3 equals x. So this should be in your notes if you want partial, if you want extra credit. Okay. Again, same situation. I want CP. That's the length of the segment CP. That means I'm going to look at the chords, and I'm going to plug them into my situation. I've got, ooh, this one's interesting. This is what I want. It's x. I know the whole part is 15. Okay. I set it up into the formula. I say this little piece here, PD, isn't 15. It's 15 is the whole part. And then if I take away x, I'm left over with this. So I have 15 minus x. I multiply them through, and I end up with 36 is equal to 15x minus x squared. I solve by adding x squared over. I subtract 15 over, and I end up with, hey, that's a quadratic formula. I can factor that to be x equals negative 12 and x minus 12 equals 0 and x minus 3 equals 0. I add 12 and I add 3 and I end up with x equals 12 or x equals 3. Both of those values will work. Okay. Here we have two secants. Oh. Okay, when I have two secants, I call the formula. I'm looking for the length of SR. So I plug in the information. PQ is 9, QR is 3, RTR is 4. And now when I plug those into the formula, I see that I have part of the chord times the full chord, or 4 times x, is equal to the whole chord times part of the chord, 12 times 3. Well, this one's pretty easy. We just divide by 4 to both sides, and we end up with x equals 9. So here's how you solve for SR on that one. Here, again, I have two secants. This one's asking me to find PR. Let's plug in our information. P equals 11. PR is what we're looking for. TR is 5. SR is 12. Plug in my formula. Notice how the part that I want isn't 11. I want to have this piece, QR. So instead of putting 11 in here, I have to take x minus 11 to find my value. When this happens, I have to distribute my x in. I have to solve for x, get it equal to 0. That's how I use my quadratic formula. So I get x squared minus 11x minus 60 equals 0. When I try and factor this, I end up with x's in the front and a 15 and 4 in the back. So I solve for this and I end up with x equals 15 and x equals negative 4. But a distance can't be negative. So that's not an option. So my answer is x equals 15. That's example 9.38. For example 9.39, we're using a tangent and a secant. So we're going to use that formula from our cheat sheet. And we say, okay, we've got tangent squared equals b times c. So here I have x squared equals 5 times 25. We square root both sides. And we know that 25 is a perfect square, so we pull up the 5 in front. And we're left with x equals 5 root 5. Example 9.40, I'm going fast. If you got to pause, rewind, that's fine. This is for your extra credit, additional knowledge. Again, I have a tangent and a secant. This time, though, I say st equals 9. So when that happens, I've got to find out what this value is. So I end up with length being what I want to know plus 9. So I get 9 plus x. When I distribute in, I have to solve for 0, right? Get everything on one side, and then I can factor it to be x minus 3 and x plus 12. When I solve for these values, I end up realizing something. So when I solve, I get subtract 12 from this side. Well, x cannot equal a negative number. Okay, this can't be negative, so my only viable answer is x equals 3. Okay. So we're going to describe how to find the length of the segments of a circle formed by two secant intersecting at external points. Okay? Put this into your own words. Basically, I want you to describe this ratio and this setup in your own words. Don't just put AC equals BD. But 1 part of the secant times the full secant is equal to 1 part of the secant times the full secant. Somehow put it in your own words. Okay. All right. A pizza has a radius of 6 inches. What is the area of the circular pizza? Circle. And we use the area formula pi r squared. R is 6 inches, then we put in 6 inches. We square it, and we end up with 36 pi inches squared. Notice that pi is not squared. If you try and square pi, you're wrong. Okay? So with this, if I take Pac-Man and he eats 60 degrees of the pizza, how much does that he eat? So how much of a circle is 60 degrees? What percentage, if you will, what portion? The ratio would be 60 degrees to 360 degrees. That reduces down to be 1/6. So he ate 1/6 of the pizza. If we use that and we multiply it by the amount of pizza that's there, we end up with 6 pi inches squared. Test hint. He ate 6 pi inches squared of the pizza. Okay. So there's your summary for 9.5. Work on the homework if you want to. It's extra credit. If you come in and ask questions, I can easily help you with them. I may post a video for 9.5 homework. We'll see. Just to get you started if you want to do it. Otherwise, there's your notes for extra credit. There.